Hello everyone, hello viewers. Today we are going to discuss the fifth chapter, chapter 5, which is all about the filters. So the filters are a very important component in the electronic system, even in mathematics and even computer science. It's very important. So today we are going to discuss filters. And we will begin with the outlines. That is, number one is going to be the definitions of filters. Number two, it will be analog filters. We also discuss about the digital filters. We will also have a look on the comparison of digital filters and analog filters. We see how they are compared. We also discuss about the ideal filters and the real filters. We also look at the complete digital filter system. We also discuss the classifications of digital filters. And remember, the reason why we are bringing in these digital there, and then, it's because that our course is all about digital signal processing. So that digital is repeating because it is like a keyword. After classifying all those digital filters, we also have a look on the finite impulse response filters and also the infinite response infinite impulse response filters. So these filters are very important. Remember, we are just trying to see the output, the response, and how does it, how do we get the output, and how is it, how can we compare it with the input? So the response is very important. That's why we are going to see the infinite and finite. And also remember, the impulse is like a beat. How does it look? Suppose if we have a sample and we want to get the output from that sample, so that impulse, like any other signal behavior, we talked about the ramp signals, the unit step, and so on and so forth, the exponential, and so on and so forth. So these ones are going to be the key for today's lecture. So I hope maybe for the next session we are going to look one by one and see how it can just bring in a new idea on this course. Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. That is chapter 5, which is all about the digital, the filters in general. We are going to see what is a filter and what are the main components or the types of the filters, and how is this filtering system is helping us in different domains. For example, in electronics, in computer science, in mathematics, and so on and so forth. So in electronics or computer science, or be it in mathematics, there are different operations, lots of operations, various operations, whereby there is mathematical operations that can go on using either the analog, the digital filters, or even the ideal or FIR or IR, which is a finite impulse response, or infinite impulse response of the signal. So the signal, as I mentioned in my previous lectures, it may be in digital form or analog form. In terms of filters, remember the main purpose of this of just getting digital is to reduce or to enhance the aspects of a signal, and that is in case of digital filters, whereby there is these crosstalks, noise, interferences that need to be removed, for example. So in this case, we are going to use a digital filter. And suppose if we are going to work on analog signal or analog filters, we are going to filter out the signals. But in this case, it's going to have, for example, the output is not going to be perfect as we want, as it should be in digital or format or in digital filters. So these are the main points that we have to discuss the filters. Remember, the filters, or the role of a filter is to supply the input is going to block the unnecessary signals or unnecessary disturbances that may come along with a signal that may just hinder our signal purification or signal appearances. So it's going first of all to block the unnecessary or the necessary the signal which is which we don't need in our output, and also by using the two forms. It can block them using digital system, which is a digital filter, or it can just block the unnecessary signal using analog. In digital filters, it's going to have two portions. Number one, it's going to separate the unnecessary signal and then restore. It's going to restore the lost signal, or somewhere where it is not perfect or it's not looking smart or not looking well, then it's going to combine the both, and the output is will be looking very nice compared to analog one. Whereas the analog is going to do the same, but the output is going to have some distortions, as I mentioned from the beginning. So this is the core of these filters. Remember, it is used to block unnecessary signal. A signal which we may not need. We can block it by using. So it's like a filtering system. For example, if you consider the filter or any filter at our homes, anything, it's used. For example, if you take a juice, for example, then the juice you put it in a filtering system. It's going to filter out the residues and then come up with a pure juice that we need. So this is very important even in the signal. That's why we need this filtering system, whereby the residues or unwanted signals are going to be left out, and then we take what we need and just come up with the pure signal that we need. So it's a normal. It can be applied even in our real lives. It's just as I mentioned in the filtering system we use at our homes. So this is the core of our topic today. So maybe we are going to discuss one by one. As I mentioned, the main components is the digital filters, the analog filters, the ID and real filters, and looking into the digital systems and their classification, and also without forgetting the FIR and the IR the signal systems. So we are going to discuss now the comparison between the digital filters and analog filters. First of all, number one is going to be, as you may be aware, or you know it from our previous lectures, the analog signal is applied by its equivalent system. This means that there is analog system and analog signal. So in this case also, the analog filters is going to be applied on analog signal only, whereas the digital filters are going to work on digital samples. That is the number one comparison. Another thing that we should remember, or we should put in our mind, is that in the analog signals we use analog devices, for example resistors, inductors, and so on and so forth. So the resistors, inductors, or the capacitors are going to be used in analog filters, whereas the digital filters, we are going to use the digital circuits or logic circuits, which will be, for example, the adders, the multipliers, and so on and so forth. So these are going to be different. You remember the multipliers, the adder systems, the multiplier system, those devices that can just generate digital equivalents, or the digital analog or analog to digital. All those things can be used, can be applied. Another differences, or the comparison we are trying to compare, is that in case of analog filter, we are looking at the stability, for example, or the response, how does it respond. So remember when we use the circle, the impulse response, in the circle we said it can be single or double response. So in our circle, remember the polar form of the Z transform, if we can recall in the previous lecture. We said some of the poles or the zeros can exist inside the circle, or others can be double, or others can be single. So in case of analog, it's going to lie in the left hand side of the circle. So for example, if this one is the circle, it's going to lie on this side, and it's going to be a single single side response. Whereas in the digital part, it's going to be inside the circle, so it's going to take all the parts of the circle. So suppose if it is you have a circle, the inner side of the circle, that's where the response is going to appear. So these are the main comparison between these ones. And also we in the analog signal, we just in getting output, we are going to approximate. It's not going to be exactly the value that we need, but we are going to do some estimation or approximations. But in a digital form, we are going to get actually the desired portion, or the desired output. The response is going to be real. So these are the main comparison between the analog and the digital counterparts.
So we are going to discuss about the advantages of digital filters. Remember, before I begin explaining this, is that the digital filters, of course, has its characteristics. One of the characteristics is the signal repeatability, or just it can regenerate easily the signal. And also some of the inputs, it can accept many inputs just in one system. Those are the very good qualities of our digital system. So today we are going to discuss one by one about the advantages of filters. I mean, those are the digital filters. Number one is going to be a linear phase generation, or the response. In this case, remember the linear response is what you have in the left hand side. It's going to be the same as what you will have in the right hand side, so that there is no signal loss along the way. So the digital
signal processing is going to be easier. There is no, in this case, there is no interruptions. So it's going to be a linear response. Throughout the course, it's going to be the same, and there is no signal loss in this case. That is one of the advantages. So another advantage is about the high performance. The performance or the signal outlook, or how the impact of the signal is not going to vary with the environment. In this case, for example, if you put your signal in digital filters, it cannot be affected by the environment. So its performance now is going to continue as usual when using digital filters. We also discussed about how there is what we call adaptive filters, or the filters which can be automatically regenerated or adapted or adjusted. So it has that quality of just automatically adjusting the response by using, for example, any adaptive filters. So another signal here, the input can be filtered out by only a single filter. You can use few digital filters in this case. What does it mean here? Or what am I trying to mean here? Is that you can have so many, as I mentioned earlier, you can have so many inputs, but still you can you can only require the digital filter. So this is very important to know that even though you have only a single filter, you can also filter out many inputs, and just blocking out the unnecessary or unfiltered signals to remain with the pure signal. Also, there is also, in terms of storage or saving the signal, the both unfiltered and the filtered signals are going to be restored or saved at the same time. So it has that capacity of just not losing the content, or losing the unfiltered and filtered out. This is very, very important, or it's very good quality, or that is the beauty of digital filter. Whereas the analog filter cannot do that, but the digital signal, now you can see it has that capacity of just bringing together the unfiltered and filtered signal, and at the same time for the future use. So also we have also the reproducibility, or how do we produce the signal, can work to reproduce the signal is going to work in the raw pace, or at the raw frequency. So the raw frequency in this case is going to be reproduced in a digital filter, and this is also a very, very nice advantage for the signal generation, because we know, for example, if there is if you increase the frequency, then sometimes the system itself can hang, or can have some problems in terms of execution or the performance. So in this case, it's going to be very nice because it has this capacity of just lowering down the frequencies as you are continuing to produce your signals. This is also very nice in terms of quality, and also it can also have a very flexibility in terms of modification, redesigning, restructuring, and so on and so forth. Suppose if you have your logic circuits, as I mentioned, the multiplier, the adder. Remember, the adder can perform very few operations, but the output, they are very effective and efficient compared to their analog counterparts. So in this case, the redesigning of those logic circuits is going to be very easy and also fast. It is going to be very fast compared to other analog filters. So these are a few of the advantages of digital filters. And remember, you are trying to get the output of in a digital format. And remember, this is the main focus of our course. The advantages of digital filters, but there is also the disadvantage or the cons, or the drawbacks or bottlenecks. So in this case, there is when you're producing digital signal, there is a speed limitation. In this case, because it will involve some of the sampling and so on and so forth, so there is a speed limitation. In this case, the speed is going to be hindered or just affected because you cannot obtain the speed as you want. Because, for example, if you are trying to bring out the digital signal, remember when it is this form and the other form that we said, zeros and ones, just completing the full cycle or the full period is going to take some time. So there is a speed limitation. The speed is going to be hindered or somehow be affected. So that is one of the disadvantage of digital filters. There's also it can have, in designing the other logic circuits, as I mentioned, it's going to take a long time in designing or development, but also this is the time. So we have speed, number one. We also have the long development and designing time of the system. So these are also the disadvantage. Remember, when you are laying out your digital or logic circuits, it is not something that you can just put at the same time then you expect the output. You have to adjust, you have to check how to obtain zeros and ones, you have to check how you can the nice position in your, for example, the printed circuit board PCB, I mean, where you are laying, for example, a microcontroller or any microprocessor or any DSC or ADC signals. So all those things you have to prepare first. So preparing them can take a long period of time, and that is a hindrance or the problem. But also the time spent also to arrange all those equipments is going to be very long. So it's going to take a long time in this case. Remember also the signal. For example, if we are using analog filters, you are trying to filter out unnecessary signals. And in most cases, you find there is this signal that it comes with distortions and noise. So just if you are quantizing or quantization of those noise signals, it's going to be is going to take the finite word lengths or the unnecessary word lengths. For example, if you have a long signal and you want to quantize each portion, for example, if it is at time 1 up to time 5, for example, you are going to treat one portion by portion and see the effect of the output of each part. And doing so is going to be tiresome or just going to be taking a long time and also just being difficult somehow. So in this case, the quantization of that noise is going to be very hard at some point, because you want to obtain the signals and also the output should be as it was expected. So the expected output in this case may take long time to reveal or just come out. So in summary, seeing what we have discussed the introduction about the filters, where we said the definition of filters by saying it can block unnecessary signals and allow or pass the necessary signals to get the output. We have also discussed about the comparison between digital and analog filters, where we said for the digital filters it can separate the unnecessary signal and also restore the signal, whereas the analog it is harder for them to compare to separate them, but also it can have impure output. The output is not as efficient as it is. Also, we have discussed the advantages and the disadvantages of digital filters, where we said the digital filters can allow many inputs and in the same system, or one digital filter can allow as many inputs as it can. But also in the disadvantages, we can see in the speed limitations, and also the noise quantization is going to take so long. So those are the summary of what we have discussed.